Hello students, we start the part 3 of chapter Indices. In the earlier two parts you have seen, children, that I have given you the basic concept in the part 1. Then I did question 1 to 10 from exercise 8 of ML AGGARWAL's book. If you are using Concise or any other standard book, no problem. Most of the question pattern is same, but sometimes questions are also same or same pattern, but values are different. So if you are using any book, you can see this video lesson, learn, do solved example and practice. So here I go to the little harder part from this chapter of Indices. So in my part 2, if you have seen, I have done up to question 24. Here I start with question 27. So question 27 says that if A is 3 and B is -2, first part you see we have to find A to the power A plus B to the power B. So if you see, this is A is 3, so 3 to the power 3 plus -2 to the power -2. How do we solve? 3 cube is 27, 3 3s are 9, 3s are 27, and this, if you know, children, negative power becomes positive in the denominator. And another thing we know, -2 into -2 will become +4. So answer is 27, 1/4. Many people, they try to find the LCM, but if this is a proper fraction, simply put it next to 27. So next question we take is question number 29, and we have given x is 9, y is 2 and z is 8. Evaluate means you have to find the value of x to the power half into y to the power -1 into z to the power 2/3. So in place of x put 9, y you put 2 and z you put 8. Now see, this can be written as 3 square. This 2 will cancel. Negative power becomes positive here, and 8 can be written as 2 cube. So you cancel. So finally we have 3 into half into 2 square is 4. So if you cancel, 2 1s are 2, 2 2s are 4, you will get 3 2s are 6. So kindly pause the video and then we will uncopy, and then we will move on to question number 32. So question 32, if you see, children, it is a proof question, so you will not get the answer at the back. What is the question? If p plus q to the power -1 into p to the power -1 plus q to the power -1 is p a to the power qb, we have to prove that a plus b is 2. A plus b plus 2 is 0. So how we go about it? This can be written as p by q. This can be written, negative power goes down, becomes positive. 1 by p plus 1 by q. Okay, so this is, you can write this side also. So here we get p plus q. If you take LCM, it will be pq. P will go q times with pq and q will go p times this will cancel. So this will go up, both are power 1, this will become p to the power minus 1, q to the power minus 1. So finally, when bases are equal, we can equate the power this side and this side, because the question is saying that in question 32 pq are different positive primes, so we cannot group them. One idea was pq to the power minus 1, pq2, so here there is ab, so equating we will get a is minus 1 and q is minus 1. Last part what we have to prove, children, is therefore we take left hand side, a plus b plus 2 is minus 1 plus minus 1 plus 2. You will see we get 0, which is the RHS. Minus 1 plus 2, you get 0. Minus 1 plus 2, you see we get 0. So hence we prove it. You can pause the video and copy. Then we will move on to question 34 part 1. So next I take question 34 part 1. So see, question 34 part 1 we have 5 2x plus 3 is equal to 1. You have to find x. Okay, so see here we get 5 2x plus 3. In my part 1 of the video where I was giving you the concept, I told you anything to the power 0 is 1. So 1, because our basic idea is to make the bases equal. So 1, we have to write 5 to the power 0, because anything to the power 0 is 1. So when bases are equal, powers are equal. So you can write here, when bases are equal, powers are equal. So 2x, this 3 goes that side, becomes minus 3. So bases are equal, powers we have equated. X is minus 3 by 2. So please pause and copy. Then I move on to 34 part 3. And children, in this chapter, in most of the book, Concise, ML Agarwal, if you see, they have solved a number of very good questions in the solved example before the exercise. So please practice them and check the answer. Don't see them, practice them and check your answer. So here we move on to one tricky question. So here this is whole root. So see what we have to do. Root means, if you see part 1 of my video lesson, root means to the power half, and this side we get 5 cube by 3 cube. So this is 3 to the power 5 half x plus 1. So here if you see, this is 5, so this is 3 by 5, this is 5 by 3. So what I do, here I can write 3 to the power minus 3 and 5 to the power minus 3. I just interchange, 3 goes up become minus, 5 comes down become minus, because ultimately we want 3 by 5. So here what will happen, you see, it will become 3 by 5 to the power minus 3. Or you could have done in another way, 5 by 2 to the power 3, when you interchange with same logic, the numerator and denominator, power becomes minus, because this is 3 by 5, this is 5 by 3. So therefore we do this. And the next part is quite easy, children, because we use the same logic. Same reason you write, when bases are equal, powers are. So next what I will do, I will equate the powers. So same reason you write here, I am not repeating. Same reason you write, since 2 dot up, 1 dot down means since, 1 dot up and 2 dot down means therefore. So here you let x plus 1 be here, you take 2 to the other side, it becomes minus 6, minus 1 going to the other side, plus 1 becomes minus 1. So we get x is equal to minus 7. So this was 34 part 3. Once more, root means power half, first trick. And second is we interchange the numerator and denominator, and power becomes minus because this is 3 by 5, this is 5 by 3. Then when bases are equal, we equate the power and solve for x. Now we move on to the question, very similar, 35 part 1. So 35 part 1, we will go and you will see it's very much similar to the question which I did just now, that is 34 part 3. See, 35 part 1 is full root over p by q is equal to q by p 1 minus 2x. So something very similar, p by q, q by p. So any one side we will change here. So I told you root means to the power half, but one small difference again is here, like previous sum, this is p by q, this is q by p. So any side I can change, this side also, this side also, minus will come any one way. I'm showing you I'm changing this side, the order. P by q becomes q by p, so power becomes half. I could have done this side also, q by p is 1 minus 2x. Same logic, when bases are equal, what was written here, you write again, powers are equal. So minus half is 1 minus 2x, 2x comes this side, minus half becomes plus there. So next we have 2x is equal to 3 by 2, x is 2 will go down, 3, 2 into 2, which is 3 by 4. So this was my question 35 part 1. So once more, I take root as power half, I interchange it, I equate it and solve for x. So now I move on to the very last question of this session on indices, is question number 39. So we are almost coming to the end of the chapter, and later on there are some very good difficult questions are left here after 20 to number 40. So later on I will put this was I think part 3, part 4. So later on you may see part 4 where I will be solving the most difficult question, and there is a chapter test also. So some question from there also I will try to solve in part 4 and part 5. But since this is the beginning of your class 9, you learn the basics. So here this is given, we have to find the value of 2, 1 plus x. So here we try to make the base equal, so 9 is actually 3 square. So when bases are equal, powers are equal. So I let x to be on the right side. Generally I want x to be the positive, and 4 comes to this side. So I get x as 5. So this becomes a simple equation, children. But the last part This is, we are not finding x, we have to find this. So always read the question properly. Sometimes children get so excited when they see any sum, if they know that they miss some very important part of question. Therefore 2 to the power 1 plus x will be 2, x is 5, 1 plus 5 is 2 to the power 6, which is 64. So this is how we do. We make bases equal, power we equate and solve for x, but x is not the answer, children. 2 to the power 1 plus x we have to find, and 2 to the power 6 is 64. So like that, what you do, the last thing I'll tell you today, which is very important, is you write like this and keep it at your fingertips like that. 128, 256, 512, like that. You can go on and learn. Same way for 3 also. 3, 9, 3 square, 3 to the power 3, 27, 81, 243, 5 also, 7 also, at least till power 3 and 4. So these are very important when you do indices, when you do log, and when you, it is applied in many other chapters. So please practice solved examples. These all unsolved examples, and thank you for watching this video lesson.